Well, today I'm going to go ahead and start on the machining of the shaft right here. That's going to be part of the welding table project here. And I got a couple updates that I'm going to go ahead and fill you in on before I get started. So I've decided to make a couple changes to the design. Nothing drastic, but it's going to involve a little bit more machine work and a couple more parts that's going to be involved in the build. So I've been doing my measurements. I've got some sketch pads here where I've been getting all of my math in order. Also on the shaft that I'm going to be machining, getting all my links and getting it all jotted down so that I have it on paper and I have all the dimensions finalized. So there was a couple things that was brought up. And one of them I haven't really delved into much to inform you. And one of them is how it's going to be grounded, the flow of the current whenever I want to weld. So the way I had this planned out was that whenever I want to use the tabletop for welding, was that I would just probably stick my ground down here on the plate. And my idea behind the welding current flow would be to come up through the tube and through the bronze bushing onto the shaft and up. Okay, I was also planning on building a little isolator bushing to go underneath the thrust bearing to protect it from current trying to flow through it. And even though I haven't done it yet, I feel like that was a solid plan. I built a small welding positioner, which I've showed in a past video in the axle housing repair. And in that design, I used 2 bronze bushings. The principle is exactly the same in that one. I had a center shaft. I got a center shaft going through it with 2 bronze bushings, and it's always worked great. Never given me a problem. That shaft is contacting those bushings in there, extremely close fit, and it always worked. It never arced, it never got stiff or anything. So that was my idea on this also. I wanted to give it a shot. But I've decided to go ahead and go a little bit further into the design and try to build it so that it has a positive, solid ground on the shaft at all times. And there's been a lot of good comments out there and ideas on how I could do that. So what I decided to do was make the shaft long and have the shaft come all the way down through it, through the plate, and attach it on the bottom side. Luckily, when I cut this piece of rod here, I just cut it off long thinking that, okay, that's plenty of material. Because I wasn't planning on bringing the shaft all the way down through there. But I actually cut this shaft the perfect length. All I've got to do is face both ends, you know, and it's there. So that with the dimensions that I need to bring the top of the faceplate to the correct height, the shaft will be coming down below here. That'll be like the bottom of the shaft. It'll be sticking out 2.5 inches, okay? So I'll get to that further on what we're going to do on the bottom of the plate to allow it to be grounded to the shaft. That's going to be another topic, another subject, okay? But just know that we're going to be working on that also. I got a really good design that I think will be nice and solid. So we'll get to that later. So the next phase is to go ahead and get this piece of shaft into the Monarch and start doing some turning. I've got a lot of turning to do on it, and there's going to be several different operations. So we're gonna use the flood coolant, do some heavy turning. We got some very coarse threading to do, and there's one more op that I'm going to be having to do on this, which is going to be really tricky, and it's going to be something new to me. I've done it before, but I've got a new tool ordered, and I thought it was going to be here by now, but it hasn't showed up because of the holidays, I think. But I've got a special tool ordered to where I can go in and do some face grooving, and that's going to be where the thrust bearing sits up inside the shaft like this face right here, I'll be machining that out so that the thrust bearing will go up inside of it. So I've got a tool ordered for that. It should be here really soon, and I'm looking forward to trying it and showing it to you. So I need to go ahead and get this in the lathe, and unfortunately I don't really have a very convenient way to pick it up into the machine. I don't have my gantry crane set up in here yet, but I've got a buddy, Gil, he's coming by later. I'm going to have the machine set up, and he and I are both going to pick that up and get it in the lathe. And once I do a bunch of turning on one side, I think I'll be able to handle it, because it's going to remove a lot of that material on one side. So that's the plan, and we'll see you at the lathe, okay? One note that I forgot to mention, might be kind of obvious. So the plate on the bottom, the base plate, you've already seen me machine. So I'm going to set that up in the mill, and I need to bore a hole in the center of it, so allow the shaft to come through. So we'll get to that later though. That ain't no problem. But we're going to go ahead and start on the shaft, okay? Okay, so I'm getting ready to start doing the machining on this first end of the rod, and I thought I'd point out a couple things here on the tailstock. I've also got another clamp that's underneath here that you use a wrench. You get in there and it helps draw up that bottom clamp tighter than what you can get with this cam lock lever on this side. So I've got that nice and snug, because I'm going to be doing some heavy turning, and we're going to be doing some chip control. This is going to be the fun part of turning this shaft right here, is making some heavy chips. So I've got two tools. I thought we'd experiment maybe with a couple different inserts. I have the one that I really love, my Iscar LNMX insert there, and if you follow my videos in S&S, you remember seeing me turn a big heavy shaft in the pacemaker at work. This is the tool that I used, and it's actually the same insert, only I flipped it around to have a nice fresh edge on it. So I'm going to give that one a shot. I've also got this Trigon type insert holder here, and that was the insert that was on it when I got it. So we're going to give that a shot, and I got plenty of other ones that I can try too. So we might try a couple different ones. Alright, so I haven't even indicated it yet, so that's what we're about to do. Go ahead and get it trued up, get us a stop set, and then we'll start some turning. All right, about 5 thousandths. There we go. It's less than 1,000 right there. We're good and tight on our chuck, so I think that'll be good right there. Okay. All right. One more thing that I'll point out: the steady rest. All right. So we've got the steady rest here. I'm not planning on using the steady rest for this part of the turning, but what I wanted to do was have it up here close to the chuck, and I'll tighten it down, because once I get through with this, I'm going to flip this shaft around. So I want the steady rest set to this 5.5 inch right here. Okay, so the other reason is when we went to set it in there, I wanted something to hold the shaft, so that's why it was on here anyway. Okay, if I had my crane in here and could pick it up, I wouldn't have needed to have that. So We're just going to slide it down here, and I'm going to check it and make sure I got enough movement. And as long as the base and everything clears, then we'll just leave the steady rest back here. All right, we're trued up. I got plenty of clearance for the steady rest here. Let me make sure that I tighten that, just to make sure it doesn't push it. Okay. Now what I'm going to do is go ahead and set a stop. And I would rather have a positive locking stop down here, but I do not have one for this lathe. And so I'm going to use my mag base like I always do. This end down here is already turned back 6 3/8, and what I want is for a total length is 21 3/4. Yeah, 21 3/4. So that's going to leave me 15 3/8 here that I got to turn. All right, so I've got me a little blue Sharpie mark, just to kind of eyeball it there. I'm going to take my square butt with my scale set on 15 3/8, and I'll butt it on that end there. The shoulder, I mean. All right, I'm going to come up here. I'm just going to line up that tool really close to the end of the scale. I'm going to leave myself just a little bit of room to face it, and that's probably about it. I got the scales on the wrong side, but let me drop it down there. So it's about a 30-second that I'm leaving myself to face off down there. I'll come back later and check that. I'm going to go ahead and set my indicator here to 0. That's a good strong magnet, so it shouldn't go nowhere. But see, I've got a blue Sharpie mark, and once I turn this on, I'm going to go ahead and scratch me a line all the way across there. That's just a visual aid, so when I'm getting close, I know that I'm coming up to my stop point. So, all right, steady rest is tight. It's not going anywhere. All right, we got the steady rest tight, so I think we're about ready to start turning. We are going to use some flood coolant today, so we'll be getting this ready, and we're going to see if we can make some heavy cuts, okay? All right, here we go. First thing I'm going to do is make me a circle here, and we're going to go ahead and try a cut. Turn the coolant pump on. Let's make sure we're getting coolant. Oh yeah. Okay. I'm going to go ahead and start with a 1/4 inch cut. We'll start with that. See how we do. And a 15 thousandths feed rate. Alright, that's 250. Let me go ahead and get the coolant going. That's doing pretty good. The coolant's getting everywhere though. All right, I want to give you a good shot of the turning action, but with the coolant going, I'm not sure how that's going to go. I've got the camera in the frame mount, so I may have to do away with how I've got it set up for a little while I turn and go put that in the solid case to protect it from the coolant. That way I can get you down here and try to get you some nice shots. I don't like the audio in the plastic case because it echoes too much. But we'll see how it goes. Let me go ahead and let's make another little cut like we got it here. I think the camera's far enough away. I'm gonna go ahead and kick the feed rate up some. I'm gonna go up to 20 thousandths. slowed it down 1 speed on the RPM. I'm going to go ahead and bring it in another 1/4 inch. I'm going to take it to a 1/2 inch and let it catch up and see how it likes it. I'll tell you what, it didn't like that. I got to find my pliers. Sometimes on the very end where it starts and it doesn't have that full engagement of the cut, it'll try to string on you, and then they get wound up and it can't break a chip. So let's see, let's try it again. Let's see if it'll do it. There we go. That's looking nice. Seems to not spray as bad with it up on the shaft here. All right, we're coming up on our half inch cut. That's a little bit much with that insert right there. I could hear it. A little bit much, but it's making some nice looking chips, man. Not this one, but some of these chips right here, really pretty. That was with that 1/2 inch cut there. All right, so I backed it off 1/8 of an inch, so we're at a 3/8 metal removal here. Let's try that. It seems to like that a lot better. Making a lot of steam, man. I love them chips. All right, I say our first cut down was pretty successful. That insert always does a good job. I went ahead and moved the steady rest off out of the way. One of the things that was worrying me was all of the chips building up right here and trying to sandwich between the two parts, so I just eliminated that problem. Everything did really good, guys. You know, those are some really nice chips right there, especially these purple ones down here like this. I'm going to go ahead with it, except I'm just going to do an even 400 depth of cut instead of 375, and keep bringing it on down. That's where it gets pretty right there. I sped the lathe up one speed. We're at 264. I've been roughing her down. I took another pass across there, and I did try this Trigon tool just for a minute. I didn't go very far because it wasn't working as good as this Iscar L&MX insert. With this one right here, it took a beautiful cut at 250 thousandths, but if I tried to go 300 to 400, it just didn't want to perform good. It wanted to pop them way up in the air, and I don't like that. This is a good style of chip right here, man. It curls them right over. But I sped it up again. I'm at 319 RPM, and I wanted to show you what it looks like. And after this, I'll probably have one more heavy rough cut to go. Alright guys, I'm down to the final heavy roughing cut that I'm going to take. Before this, I was doing some miking here to see what I was getting, and I was running into some taper issues. So I've actually been spending a little time over here trying to get my tailstock aligned right. So I've got her pretty dang close now. I'm like within a half a thousandths from this point to this point, and I've made 3 cuts to try to verify that. That's 411. That's 411 and a couple tenths. That's 411. So I mean, I think we're pretty good right there. Above 3 inches. So basically got 400 thousandths to come off. So we're gonna make one more big cut. I'm probably just gonna take 350 on the dial. I've already touched off here. See, it actually does better making a heavier chip than the smaller chips. See where we finished it at. Okay, 49. Changed on me that time. Man. Alright, we'll get it there once we make our finished cuts. That's why right there. I forgot it was okay. Now I'm getting about 2 thousandths right here. After where the smaller cut was, it kind of picked off, pushed off, and it's a little bit smaller right in here. Okay, my next phase is to go ahead and turn this section down. I want this to be, we're going to go ahead and make this one size smaller. We're going to turn it 2 7/8. Alright, this right here is where our bushing is going to run. We're going to finish this to 3 inch. So the rest of it we'll make 2 7/8. Alright, from this face back I want it 6 1/4. Alright, 6 1/4. Double check it. Six and a quarter. Just put a little witness line there to follow whenever you're turning. This right here, I have in the past, whenever I'm doing turning like this, you do all this rough turning so you're already used to this distance here, and then you change things and you're only wanting to turn to so far. I have messed up and gone past where I wanted to turn before because I wasn't paying attention to what I was doing and was thinking that I'm going on down again to this next shoulder. So got to pay attention. All right, let's touch off and take 100 thousandths. You get about 2 thousandths. I think that will work though. All right, ain't got much to come off. We got about 75 thousandths right in here that I need to remove, and this is not a critical diameter right here. That was my first semi-finishing pass, and now I'm ready to take my finish pass across here. So we're just miking. I'm gonna go ahead and move the coolant because I'm not using that. Turn it off too. .907. We're taking this to 2-inch 875. That's .907. That's 908 right there. So I'm still getting about 1 thousandths taper in it. We're gonna, I've always got taper problems because of the wear in the machine, but we're gonna leave it alone. That's not bad at all. I'm gonna base my cut off this 907 right here. So I'll take 32 thousandths, and hopefully that'll land me on 2-inch 875 on this end here. Okay, here we go. And I just want to point out, man, the Lathe's doing excellent. I'm not getting any kind of chatter problems in here or anything. That's the tailstock, you know, stuck out like it is with the quill anyway. But the machine's handling it good. This tool's leaving a nice finish. That's a 10,000 speed rate. So you get a little bit of the lamination look in it, but there's very little that's going to get done to that right there. Right. $875. 876, actually about 76 and a half. Very good. I call that plenty straight enough. It's got a really nice smooth finish on it. Alright guys, I'm going to call it a day. I'm going to leave this where it's at. I've got my tool that I ordered that I'm going to come up in here and we're going to do some face grooving right here on this face. That's where our thrust bearing is going to go. And I'll also get this down close. So we're only about 40 or 50 away right here, but I want to leave it alone. I don't want to take it down any further. So it's coming together. It's looking good. Been having some fun making some heavy chips, getting to use our flood coolant that I fixed. I'm enjoying it.